Okay, Algebra, we're going to study for your Chapter 4 test. So it's going to include functions or not functions, I guess telling if it is a function or not, telling if it's a linear or not, and telling questions about domain and range, and using function notation. So let's go ahead and get through it. Function or not, by looking at a graph. So you need to have something that is. To look at a graph and tell if it's a function or not, you can use a vertical line test. So for example, here is a vertical line. Let me make it stand out a bit for you. How about I'll make it, I don't know, make it blue. Okay, so I'll take this vertical line, I'm going to drag it across. Now as you see, if it touches the vertical line in more than one spot, it is not a function. So as you see, it touches it right here, and it touches it right there. That makes it not a function. So this is a non-function. Non-function. Okay, we'd use vertical line test here. It only touches at one spot every time, everywhere I move this vertical line. So this is a function. Function. Same thing here. It only touches it at one spot. As you see, it's touching it right along that blue line, just in one spot. So that is a function as well. Down here, function or not. Touches it once. Right here, it touches it twice, up there and down there. So this is not a function. This is a non-function. And as you see right here, this is going to match up everywhere along that line. So this is a non-function as well. This one, function. You see, follow along. It only touches that blue line only once. Okay, so you have non-function. This one is a function. This one is a non-function. This one's a non-function. And this one is a function. Okay, hopefully that's easy enough for you. Looking at the table, so basically when we're trying to determine something is a function or not, you just got to see if the x's repeat. So do you see any x's repeating? Nope. So this is a function. Reason being that if we graph this, there would be no vertical line. It would pass the vertical line test rather. Okay, x's repeat here. This is a non-function. Look for repeating x's. This one's okay. This is a function. And basically the same idea with ordered pairs. And if you look, I just took these and made an ordered pair. So, I'm sorry, I guess I used a different one. So, ordered pair. Look and see if the x's repeat. This doesn't repeat, doesn't repeat. Oh, look right here, 4 repeats. This is a non-function. Does a 4 repeat? Nope. Does a 5 repeat? Nope. 0.2 repeats? Nope. 5 up. Oh, there's another 5. This is a non-function. If the x's repeat, it's a non-function. That's all you need to know. Linear function or not. So we're focusing on the linear part now. Is it a straight line basically? So straight line? Yes. It's a linear function. Straight line? Yes. Linear function. Straight line? No. It's got a little bend to it. So no, this is a non-linear function. Straight line? Obviously non-linear. Let's move on. Linear function or not, using the table. So basically we need to look at the changes. Here it grows by 1. Here it grows by 1. And this one grows by 1 as well. This one grows by 4. Grows by 4. This also grows by 4. As long as it stays consistent on each side, so this is 1, 1, 1, 4, 4, 4, this is yes, it is a linear function. Grows by 2, 2, 2, so we're okay on that side. 3, 3, and 3, we're okay on this side. Yes. Grows by 1, 1, 1. This side grows by 1, and then it grows by 3. Okay, so then it grows by 5. So this is a non-linear function. It's not linear. Okay, right here it grows by 2, grows by 2, grows by 2. We're alright on that side. This is growing by 1. This is growing by 9. So right there you can tell that it's non-linear. Then it gets smaller by a lot. So non-linear. And basically I took this table right here and I made an ordered pair. You can do the same thing. Check the x's. Grows by 1, grows by 1, grows by 1. And then look at the y's. Grows by 4, grows by 4, grows by 4. If you don't like that, you can make a table out of it. Just list your own table. -1, 8, 0, 12, 1, 16, and 2, and 20. You see, it's just a table that I made right here. Excuse me, sorry about that. Look at this one. These order pairs are basically this up here, so it's the same thing. Okay, and so this is going to be non by the same reasons. Let's go to the next one. Domain is the x value, range is the y value. So list the domain in the set of the ordered pairs. In the set of ordered pairs. So here is a group of ordered pairs. List the domain. The domain is all the x values. So if I ask you to list the domain, you just got to write them all down. It'd be nice if you put them in these little squigglies. That just means it's a group of the group of domain. But you don't really have to. It'd just be nice. And it would be, you really want to get in the habit of putting them in order from smallest to biggest. So the lowest x value, -2. The next lowest is 4, then 5, and then 9. So this one, this one, this one, and this one. Okay. Those are domains. Then the range is the y values. Once again, you want to get in the habit of putting it in order. So the lowest is -3, then it goes to 2, then it goes to 7 and 10. Okay, this is the range. This is range, this is domain. Domain is x, range is y. You don't have to put them in squigglies, just be nice, but you should really try to put them in order, smallest to biggest. Given the domain, so that means these are the x values. List the range using the function. So you're going to try and find the y values, which is basically the same, y values, which is basically the same as this f of x thing. It's just a different way of writing y. That just means that the function when x is some numbers. So we'll do the first one. The function when x is 4. Plug it in. This is 12 minus 2. This means that the function when x is 4 is going to be 10. So that's one of your range values. So sorry, I wrote it down here. So one of them is going to be 10. Do it again. Function when x is 6. 3 times 6. Sorry, that's really messy. 3 times 6 minus 2. So this is 18 minus 2. This is going to be 16. So the function when x is 6 is going to be 16. That's going to be my next one. Do it again for 7. You get 3 times 7 minus 2 is 21 minus 2, so it's 19. And when x is 10, you get 3 times 10. Then we're going to subtract 2, so you get 30 minus 2, which is 28. So these are the range values right here. Okay, so you got 10, 16, 19, and 28. Once again, it'd be great if you put it in these little squiggle things. I know they're hard to make. Try to put them into order. Evaluate f of 2 in the function f of x. Remember, this is read f of x. That's really sloppy again. This is how you say it. F of 2 f of x. That's how you say this. So this just means when x is 2, plug it in. 4 times 2 plus 1 is 8 plus 1. It's going to be 9. So when f of 2 equals 9, means when the function when x is 2 is equal to 9. Evaluate the function h of x. So when x is 3, what's the answer? So this is 15 plus 2, 17. So when the function when x is 3 is going to be 17. This is the way you should write it. Really, I'm just going to check this part. But if you want to get really good at math, this is the way you should write it. And I think that's about it. A little bit under 10 minutes. Sorry, I was trying to make the video short as I possibly could. So good luck in your studying. Let me know if you got any questions.